Now, let's look at types of numbers. Okay. In the TEAS exam, they don't care about whole numbers or integers or anything like that. They only care about three things, okay? Rational and irrational. Okay. So rational numbers, let me erase it. Let me start it from over here. Okay. Rational numbers can be written as a fraction. So it doesn't mean that it is a fraction. It means that you can convert it into a fraction. So it could be a decimal that you can convert into a fraction. So, right, the easy ones, right, to know are, hey, these are fractions. That's a fraction. Okay. But something like 0.25 is equal to 1/4. So if I have a decimal that ends, right, this decimal does not go on forever. Okay. Or I can have a decimal that goes on forever. But it repeats, right? So even before I write that, let's say this is equal to 0.333, goes on forever. Okay. So a decimal that has a bar or repeats forever. Okay. Now it doesn't have to just be one number. It could be 5.2123 bar. So that's 5.12. Oh, sorry. 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. So more than one, you know, a certain sequence can repeat forever. Okay, it doesn't have to be just one number, but at some point it has to be repetitive, even though it goes on forever. Or just regular numbers, 5, -7, 0. All of those are rational. So let me let you copy that. Okay. Now, this is the bubble that is rational numbers. Okay, they're a number that some way can be written as a fraction. Okay. Now, there's another bubble, which is the opposite of this, irrational numbers. Irrational numbers cannot be written as a fraction. Okay, so let's write that. Irrational numbers cannot be written as a fraction. Okay. So what are those numbers? There are numbers that look like a square root that cannot be resolved. So a square root of 4 would be over here because square root of 4 is equal to 2, and 2 can be written as a fraction. But square root of 2 here is equal to, oh, where's my calculator? One 1.414213562 dot dot dot. So it's a number that goes on, it's a decimal that goes on forever but never repeats. Okay. So anything with a square root. So they can multiply a square root that doesn't resolve, or they can do a square root plus some number. Any square root that's not a perfect square root, and if you add it or multiply it or divide it, doesn't matter. Adding it, multiplying it, dividing it, squaring it, none of that makes it rational. It just stays irrational. Okay. So 1 is a square root. 2 is a number that repeats forever but never I'm sorry, a decimal that goes on forever but never repeats. So a lot of times on the test, they'll write it like this. Which is different from this because you see it repeating, whereas over here, you don't see it repeating. Okay. So here is number 1. Here is number 2. Okay. And number 3 are basically Greek letters. So if you have something that looks like pi, pi is equal to 3.141 dot dot dot, or e is equal to 2.72 dot dot dot. And sometimes they may have tau, 1.6 dot dot dot. Okay, so if you see a Greek letter, because this number has infinite precision but never ends, they give it a name, kind of like Prince. You know how Prince had that little symbol? These irrational numbers have a name, pi, e, and tau. These are the three that might show up on your exam. Okay. Now, what I tell students to do is don't memorize this list. Memorize this list. This list is way easier to memorize. Okay. So again, I'll put a little star here. This shows up on your exam where it'll say, is it irrational, rational, or real? Okay. And it's easy to memorize this list, whereas this list gets pretty long. So do I have a square root that doesn't resolve? Do I have a decimal number that repeats and goes on forever? Or do I have a Greek letter? Okay. So these are two separate groups. You're either rational or you're irrational on your test. Now, everything on your test is real. So no matter what, you always click real. So the group that contains both of these are real numbers. Okay. So on your list of things to look at before you take your test, that right there, right? Night before, remind yourself. 3 things. Okay. Now I gave you some homework. Let's take a look at that homework. Okay, so let's pop that up and let's do some of them together. Okay, so this is the types of numbers. Okay. And remember, do all the homework and then send it to me. Don't send it to me in bits and pieces. Okay. Um, let me share a screen. Okay, good. Let's make this a little smaller. There we go. Okay. Now remember, we only care about these 3 columns, the last 3. Okay. So go ahead, work your way down. Okay. Now, no matter what happened, all of these are real. No matter what. Don't even have to look at it. On my test, I know everything is real. Now remember that you'll never click on both of these at the same time. So any answer that says rational and irrational, cross out. Any answer that doesn't say a real number, cross out. It always has to be real and one of these. Okay. So that has a negative square root, irrational. That's just a number. That's okay. That's okay. That's okay. That's a decimal that ends, and that's a decimal that repeats. Now, this one, notice that I have 1 0 and then 2 zeros and 3 zeros. So even though there's a pattern there, it's not the same number repeating over and over and over, the same pattern repeating over and over. So that one is irrational. Okay. So that's just a number. Ignore that one. I don't think they'll give you this one. This one is nothing. So actually, let me erase that one. Okay. A number divided by 0 is undefined, so that's not a number. Okay. So pi is a Greek letter, right? And then this 0.634, it repeats over and over and over. Okay. Now this one over here is a little bit tricky. They're being a little tricky with you. If you use your calculator, this will be equal to 15. So that's actually rational because it can be resolved. Right? It's a perfect square. Same thing over here. This one is equal to 2 over 7. So that's a fraction. And then that's a square root, so it's irrational.
I thought 10 was irrational
Which one? 10?
on pi.
Oh, it is pi. I said irrational and then I clicked the wrong spot, didn't
Professor,
I?
I thought number
Yes.
7 was rational because it's repeating itself.
It's repeating, but it's not like 05, 05, 05, 05.
Oh, gotcha. I see. All
You
right.
got it. So there is a pattern there, but it's not it needs to be 05, 05, 05. Like the same number showing up over and over and over again. Okay. So does this make sense to everyone? So on your exam, this is a quick kill, meaning that if I know this, if I know those three things, I can knock this one out pretty quick. So let's take a picture of this. Okay. Okay. Now, the next one I want to work on, and this one seems to come up a lot. Okay. So let's look at your last homework. Okay. So let's look at this one right here. And let me share screen with you. They seem to like asking questions where you estimate what square root of 2, square root of 17, square root of 11 are. They like to ask that. They like to ask it in different ways, like what number is this closest to? And they'll give you a bunch of options. Or they'll give you something like this, where they'll say, which number is bigger? Or they'll give you something like this, and they'll say, I have a square root, a decimal, and a fraction, and I want you to order these from smallest to biggest. Okay. So this is a good worksheet because this is something that kind of pops up. I'd be surprised if you didn't get one of these questions. I think you'll probably get. Okay.
I have
Now,
one question, Professor.
yes, please.
Why is the 4.56? You know, just the table rational and irrational.
Oh, okay. Let's see.
Uh,
Let me share screen again. So let's go back to here. Which
number
number?
six. Number six.
Number six.
No,
Oh,
why
okay.
is this one is rational number?
Oh, see how I have a bar there?
Uh-huh.
Anytime I have a bar, it makes it rational.
Okay, got it.
Okay, because then it repeats. So this one over here, see how 634? As soon as you see a bar, you know it's rational.
Thank you. Got it. Thank you.
Okay, thank you for your question. Okay, now. Okay, so this is one that probably shows up every so often. But if it does, you should get this one right. Okay, now let's talk about estimating square roots. Give me 1 second. Let me remind myself to send you the video also. Okay, now. Excuse me. What we want to use are square roots as sort of markers of where things are close to. So if I look at something like square root of 38, I don't know what square root of 38 is, right? But if I look at the perfect squares that are near 38, this is 36, and this is 49. It means that 38, it's in between 6 and 7. Okay, so what you want to do when you're trying to estimate a square root, look at the perfect squares that are bigger and smaller than it. Okay. Excuse me. Okay. So we got a little bit of information over here. Okay. So I know that if you ask me about square root of 38, I know it's in between 6 and 7. Okay, let me give everyone a chance to copy. Okay. So if I was to give you, oh, by the way, on the square root worksheet, I don't have a solution key. So you'll just have to use a calculator to find out, to figure out which one is, if your answer is correct or not. Okay. Okay. Now, so when we look at this, if I asked you a question, which value is square root of 38 closest to? You had A, 5.2, B, 5.8, C, 6.1, D, 6.9, E, 7.2. Okay, so go ahead, write that. Okay, so let's look at this. So we're saying 38 is between 6 and 7. So the only two numbers I'm looking at is this right here, right? Because 38 is in between 6 and 7. Now, the question is, which one is it closer to? Okay. Look. 38 is closer to 36 than 49. So if we were to look at a number line, we would say that this point is much closer to 6 than it is 7. So we would use this right here to tell me, well, it's in between those two numbers. So these are the two I'm considering. And from the one I'm considering, it's closer to the smaller number. Okay, let's try that again. Okay. Which value is square root of 98 closest to? Let's do that. Oh, give me 1 second. Sorry about that. My boss called. And you always got to answer when your boss calls. Okay. So let's look at the perfect squares here. So if we're going to look at the number line, well, let me use a different color. So if we're going to use the number line, this is in between square root 100 and square root of 81. So this one is 10 and this is 9. And when we look at square root of 98, like where is 98 in comparison to 81 and 100? It's not near 81 and it's not in the middle. It's really close to 100, right? So if you're to estimate it, it's not perfect, but if you go like 98 is really closer to 100 than it is 81. It's really not in the middle. It's really close to here. Okay. So I need a number that's between 9 and 10, right? 9 point something. So that tells me it's this one. Okay. And the fact that 98 is closer to 100, I'm going to go with this one. Okay. So let's take a picture of this. Let's try another one. So let's take a look at this. Okay. Which value is square root of 26 closest to? Okay. So now we can look at square root of let's see, A, B, C, D. Okay, so I'm going to have 5.1. Oops, I'm sorry. 6.1, 5.1, 5.3, 4.2. Oh, wait. I did something wrong. Give me 1 second. 5 and that's not the one I want. Okay, I want put 35 here. Okay.
$5.3.
Let's see. You good? All right, I'm trying to trick you on this one. Okay, this one's not easy. Okay. So let's do the number line. Okay. So we have over here, we have square root 25. Over here, we have square root of 36. Okay. So this one over here is 5. Over here is 6. And then over here, we have 5.1. And over here, we have 5.3. Over here, we have 6.1. So square root of 35 is going to be pretty close to over here. Right? So you can sort of see how these are all bunched up over here. Most likely, this is going to be closer to 6.1 because see how these are way far away on the other side of close to 5, whereas this is really close to 6. So in this case, it'll be 6.1. Does that make sense at all?
Yes, on a number line, yeah.
Yeah. So this one is really close to 6. So 6.1 is probably closer than all of these that are really close to 5. Okay. Now let's do something a little bit nasty. Okay. Now these two numbers are going to be very, very, very close. Okay. Insert less than, greater than, or equal to. I'm going to say square root of 30. Okay. And then this is 5.5. Now these numbers are really close. Okay. Now understand that this will never be equal. Because this is rational, right? It stops. This is irrational. So no matter what, it will be less than or greater than. Okay, but using this technique over here where you're kind of saying like, okay, I have my little number line. I have square root of 25. I have square root of 36. And then I have 5. I have 6. I have square root of 30. Crap. That's in the middle. And 5.5, that's in the middle. How the heck do I figure this out? Because they're both really close to each other. Okay. Now, the way you figure this out is you just square both sides. Right? Think about it. 4 is bigger than 3. If I square both of these, 9 is still bigger than 16. So the easiest way to figure out if you're doing like this and they're really close, you just square both sides. So this square and this square root, they cancel each out and I get 30. And over here, remember, you have a calculator. It doesn't have exponents, but it does allow you to do multiplication. So if one number is bigger than the other, when you square it, they stay big. So then this becomes square root like that.
Professor, can I ask a question?
Sure, please.
For the purpose of the teas and the purpose of time management, for this kind of question, can I just solve square root of 30, which would be 5.5.47722, blah, blah, blah.
Well,
And
remember, your
that-
calculator has only 4 operations. Plus, minus, multiply, divide.
The one that it's on, the one they provide on the screen, right, during the teas.
Yes, yes, there's
Gotcha.
no square root.
Got it.
Okay,
That-
so there's
that makes
no
sense.
square root and there's no square, and that's why we're putzing around with this. Otherwise, I'd tell you, you know what, square root the sucker and move on with your life. Okay, so let's do that. So let's give you another one to try.
Thank you, Professor. This is a very cool method.
Okay, good. All right, so let's give you another one. So let's give you okay, so let's go 6.5. And then let's go square root of 42.
— 6.5 is greater than square root
Is
of
it?
42.
Okay, let's try it. We're going to square both sides. Okay. So we're going to square, and then this will cancel that. So I get 42.25, 42, so that's bigger. So yeah, you're right. Okay. Now, the next thing they like to do is they like to ask you to order these things.
Professor, can we do one more?
Say that again.
Can we do one more example?
Like this? Okay, let's do one more. Okay. So insert less than, greater than, equal to square root of 7, and then 2.6.
Thank you.
Okay, is that better? Okay, so then let's square both sides. So I have square root of 7, and I have 2.6. So I get 7, and then 2.6 squared is 6.76, and this is smaller. Okay. Now, the other thing that they like to do is they like to ask you to write numbers from increasing to decreasing order. Okay, so let's go 5 1/4. Let's go square root of 38, and let's go 0.5. Oh, sorry, 5.9. Okay. And you know what, instead of this one, let me put 21/4. I apologize. I know you guys copied. Okay. And then over here, let's do 40. Okay, so big number first, small number last. So whenever they give you a fraction, what they want you to do is they want you to convert to a decimal. Okay, it's a lot easier to convert decimals than it is fractions or anything else. Okay. So this is 5.25. Now, what I like to do is I like to pad it so all of my decimals have the same number of digits after the decimal. So it's easier to compare this and this, because sometimes you make the mistake where you go, this 525 is bigger than 59, and the answer is no. So I like to pad it with zeros. That way I won't make a mistake. Okay. So if you put this on a number line, okay, so let's make sure we put our square roots. Okay. So I have square root of 36. Oh, sorry. Square root of 25 is 5. And then I have square root of 36 is 6 over here. Okay. So my 5.25 is here. My 5.9 is there. And then my square root of 38 is here. And my square root of 40 is there. Right? It makes sense that this number is bigger than this. So when I square root both, that 40 will be bigger. So then this turns into, right? We go big to small, square root of 40, square root of 38, 5.9, 21 over 4 like that. Okay, let's try that again. Let me take a picture.
Professor, is there a way we could easily convert the square roots without the calculator into decimals there?
No, it's hard. That's why you kind of have to fudge it this way. So unfortunately, there isn't a great way. Now, if you wanted to compare 5.9 and 38, we could use the technique I just showed you where you just square both sides, right? You could use this if two numbers, if a radical and a decimal are close, you could use this to determine which one goes first, which one is smaller, which one is bigger. But unfortunately, there isn't an easy way of doing it. You actually have to use Calc 3, and it actually takes quite a long time to do it. Okay, so let's try another one. Let's try 7 over 2, and let's try square root of 10, and let's try square root of 12. And then we'll say write numbers in increasing order. Okay, so this time I'm telling you go from small to big.
You actually just taught me how to do this very easily, like converting this into decimal, this square root. It's
Yes,
easy.
yes,
Oh, yeah,
yes.
thank
So,
you.
yeah, so go ahead, try it, right? So you're going to get the 3.5 here, right? So you know the square root of 10 is smaller. So the question is square root of 12, and then it's 3.5. That's the only question. Which one is bigger, which one is smaller? So go ahead and use this technique. Okay, so let's try this one. Okay, so let's see which one is bigger and which one is smaller. I have square root of 12 and I have 3.5. Now let's square both sides. Okay. So we get 12 is, and then 3.5 squared. Let's see.
It's 12.25.
Oh, okay, thank you. 12.25. So now we know when we look at this that we have square root of 10 and that we have square root of 12 and then we have 3.5. So square root of 10, square root of 12, and then 7 divided by 2 like that. Okay. Okay, thank you, everyone. In terms of the haiku, instead of using my password and us getting in trouble, I'm going to send you a link. So I'm going to do a bunch of things. Okay. I'm going to send you the email. Okay, I'm not email. I'm going to send you the video. I'm going to upload it in YouTube. So it's going to take me like an hour or two to do it. It takes YouTube a little bit. So I'm going to upload it onto YouTube. So it's now, it'll be available for you forever, right? You can just look at the playlist. I will send you the link to register into Haiku. So instead of using my account and me forgetting and getting in trouble, you can create your own account. It doesn't cost any money, but it'll, when you get into Haiku, it'll be under your name, not my name. So when you go into the nursing program, you can use the same account to access both. Okay. When you okay, so those two. I'm going to send you pictures of what we just did, and I will also resend the homework because I kind of sent it in 2 different blasts. So I'll reorganize everything that I sent in the morning. I was a little bit frazzled, and I'll see you guys next week. So before Friday, on Thursday, please email me your homework. On the top, say T's homework, and please put it all in one email. Okay? If you want to put multiple pages with one picture, I'm perfectly fine with that. Okay? Remember, I gave you answers to everything. Check your answers as you go. Okay. Thanks, everyone.
Professor, I have a question.
Sure.
I have a question. You said you give our answer and the homework.
Yes.
Where?
The homework all has answers except for the one that does comparison. Just use a calculator to double check your answers.
Okay, you said we have to print out. We have to print out the homework, then do.
Yes, print
Now,
it.
if we don't print out, we how to do your homework? If we don't need to print out,
So
can
if you want,
we directly do the online, then send send to you?
yeah. So if you just directly write it on a piece of paper and you don't print it out, take a picture of it, that's fine too.
Then send to you through emails. If someone doesn't have the printer, how to do your homework?
Just write the work on a piece of paper.
Okay.
I don't actually need, just say number 1, here's my answer. Number 2, here's my answer. Number 3, here's my answer. Oh, and I did a little bit of work. Number 4, here's my answer. I don't actually need you to actually print it. I just need to see that you did it. That's all.
Okay, it's send to you through email or through your phone number.
Never send it to my phone number.
Send through email.
Email, yeah.
Okay, thanks. This is the computer technician. So this for me, I don't know. For me, so difficult. This to now I have the printer, but I don't know how to use. I don't know.
Yeah, don't worry about it. Don't worry about it. As long as you can open it up and just do the problems, I don't care.
Okay, but if I do after I do, how to send to you? I have to if I answer all of the questions, then I have to take the picture. I have to scan. If I take the picture,
Not scan it. Just take a picture, and then from the picture you send it to me.
For picture, how send to you?
Okay, so let's do this. Let me stop recording here. Anyone else who wants to take off, you can.